Welcome to the Contagious Code Podcast, where we dive deep into code, learn practical skills, celebrate the beauty of engineering, and eliminate imposter syndrome. I'm Tejas Kumar, and I've been building on the web for over 20 years at places like Vercel, Spotify, Zeta, and more. Today, my guest is David Khourshid, or as some know him, David K. Piano, or as others know him, the State Machine Guy. David is the founder and CEO of a company called Stately, Stately.ai, that is a sponsor of the podcast, and is also the author of popular state management library for React, XState. David is a subject matter expert on state machines, sometimes called finite state machines or finite state automata, and state charts, and really everything in that space. What's also less known about David is that he is a CSS expert who creates really great things with CSS, and this is somewhat overshadowed, unfortunately, by his state machine activity. In any case, Stately and David, its founder, are just brilliant software and human, respectively, and in this episode, we uncover a number of things. We uncover XState, the need for state management libraries around in the JavaScript ecosystem, but specifically in React. We talk about when you might need a state management library, and we talk about resolving conflicts with parallel state management, things like CRDTs and so on. We then pivot and talk about Stately, its unique offering through its visualizer and its way to model state through your application. We then move to the future of Stately, including using AI for state machines. And we talk about David's newish project called Stately Agent, which is a way to create AI-based agentic workflows using state machines, using XState. And so all of this discussion is for you. If you've ever wondered about state management, state charts, the distinction between state charts and state machines, React, AI agents, or more, this episode is for you. I'd like to offer this to everybody at zero cost. In fact, this is zero cost, and the way we can keep it zero cost is through sponsors. So let's take a moment and acknowledge our sponsors, and then we can get into the discussion. This podcast is partnered with Code Crafters. Code Crafters teaches you how to do things using a language you know, so cementing your programming language knowledge, and the things that it teaches you how to do cements your understanding of various tools, because Code Crafters teaches you how to build like Redis and Git and Docker from scratch in a language you know, so that you better understand those tools by implementing them, and you also better understand your programming language by implementing those tools in them. It's a great way to learn, and they've offered all listeners of the Contagious Code podcast 40% off if and when they start paying. To take advantage of this, go to tej.as/codecrafters. There's also a link in the show notes. The podcast is also sponsored by or partnered with That Conference. That Conference is a multidisciplinary tech conference, that means front-end, back-end, etc., that happens twice a year, once in Wisconsin, once in Texas. If you want a free ticket, share this on social media and say, I want a free ticket to that conference, and you will enter a raffle to get it. Again, we thank you to the founder of That Conference, Clark Sell. We have an episode coming out with him soon, and we are ever so grateful for your partnership, and we can't wait to send people there who listen to the podcast loyally. Now, thanks for sticking around. Here's my discussion with David Khourshid. David Khourshid, man, we've spent so much time at various conferences talking about so many things. You explained, I'll remember this, we went out to get coffee once very early in the morning, and you explained the actor model to me, and I was like, yo, we have to record this and tell more people about it. So I don't remember exactly which city that was in, but I do remember the conversation.
Yeah, we've been in a lot of cities and had a lot of conversations. So, yeah.
And now finally I get to have you on this podcast that I just started. So I'm hugely honored. Thank you for being here. I'd love it if you could give maybe a short introduction for the listeners, who you are, what you're up to. You're probably best known for XState. We're going to talk about that. But in your own words, the stage is yours.
Sure, yeah, and I'm extremely happy to be here talking to you too. So yeah, I created XState about 8 years ago. I founded this company called Stately.ai, or startup, about 3 years ago, a little under 3 years ago. I was at Microsoft before that. I've been a developer for, I want to say 15 years. I always lose track because what is time? And yeah, so I also play piano. That's why my username's David K. Piano, even though that's not my last name. It's just what I like to do.
You have a bachelor's degree, right? In that, in piano.
Yeah, that's right. So I went to university for piano, and then later in my university years, I just transitioned to computer development. So I've always been interested in it, but being a developer pays a little bit more than a musician.
Yeah, it's in both cases you're sort of playing a keyboard, but one for whatever reason is more lucrative than the other. Awesome.
Exactly.
Thank you for that. So Stately, 3 years in, XState, etc. I wonder. Let's maybe start by talking about XState, the state management library. XState, obviously, a solution to the state management problem, alongside things like MobX and Redux, now Redux Toolkit and Jotai, I think, and there's a whole slew of these. Let's zero in on XState. Actually, maybe we can start by outlining the problem space. Like, why do all these libraries exist, and why is XState one of them? And do they all solve the same problem? Probably so, but do they solve it in different ways, and how does XState differ?
Yeah, that's actually a really good question. Because state management, it's if you look at it as is, it's not really a problem. It's like the language, the natural JavaScript language or whatever language you're working on, it already gives you the tools to update state. Like this is something that you're taught in, the 101 course of how to work with this programming language. It's like I know how to update states. But when you get into frameworks and libraries that sort of expect you to update state in different ways, then you have to consider things like immutability, just and maintaining the same reference of things if you don't want things to change. So things like memoization, caching, and stuff like that. But then things get further. So I see it as like different levels. So, I'm sure a lot of people listening might use React. React already has built-in ways of handling states. You have useState and useReducer. You have useContext, which is arguably for states, although, maybe not. Yeah, like you could do, I would say, 75% of your state management using those hooks alone. Async state can be handled using, well, now with React, you have the use hook, etc. Basically, what I'm trying to say is that it's an interesting question, like why are there so many state machine libraries if it's already pretty much a solved problem? The problem comes with organization and managing more complex states. So for instance, if you need to manage states that that needs to be shared between components, you have Redux. That's how Redux became popular. It's like, okay, now we have this global store, and XState sort of just solves things at the further end of the spectrum, where the more complex your application logic gets, you need to think about your state a different way. And so XState embraces two main things: state machines and the actor model. And so with state machines, you define that your app is in specific states at a time, or parts of your app are in specific states at a time, and they can't be in more than one state. And so a state can be like viewing the checkout page and then viewing the carts or viewing the payment screen, etc. It's like you don't want to be in two states at the same time. And also defining transitions between those states, and those transitions are triggered by events. And so this actually gives a mental model that makes dealing with complex state, I don't want to say easier, but simpler. It gives you a simpler model. It gives you the building blocks to when requirements change, or you get more requirements and features and things like that, then your state is still predictable. It's still something that you could reason about. It's not something where you're going to tear your hair out because you have a mess of if statements and just logic all over your UI and stuff. It gives you a nice centralized place of dealing with your state, because application logic does get more complex the more features you add to it. And we're not all just building simple apps. We're building really, really complex apps. Unless we're making toy projects. So in short, something like XState and state management libraries in general, they solve the problem of this logic growing in complexity. And that's definitely what XState purports to solve too.
Okay, I love that you something I try to do on this podcast, and something I value really highly, is drawing a line from the basics all the way through to the complex. And that's something you just did pretty masterfully here, because you mentioned, okay, state management is look, you can do like let var equals value and then update that value, and you're sort of managing state, you're working with state, and you said that's state 101. And the reason these libraries exist is because state can grow more complex. And you alluded to the idea that state grows more complex because well, there's frameworks and libraries that introduce those complexities. For example, React will introduce like immutable patterns and so on and so forth. You mentioned, okay, so Redux was invented to solve a specific state management problem, which is sharing state across components with the global store. You said XState goes to higher or maybe even extreme levels of complexity. And you sort of touched on that briefly when you said async state. But I'm curious, like, what is the worst possible case of complexity look like, and how can stately XState, excuse me, solve that?
Oh man, you know those YouTube videos where it's like 6 levels of X or
Yeah.
whatever. It feels like that. So um, basically, I would say at the furthest end, you have distributed state, distributed applications where logic is living in many different places. You need things to communicate with each other. You have this asynchronous communication. State doesn't live in one place, and it's like, how do you herd these cats? Basically, like, how do you make sure
Right.
that that your application is still working as expected when things are just in a distributed fashion? And distributed computing is hard,
Yeah.
and so that's why, at least with XState, it embraces, like I said, state machines in the actor model, which were specifically created to solve these kinds of complex problems. Now, because of that, XState might seem at times a little bit complex for simpler use cases, but uh, the purpose of it is to deal with more complex logic.
Yeah, and it's proven its value. I mean, it's used by a number of last I heard, it was used by like NASA. Is that accurate? I heard some big names using XState.
Not NASA, but there are big companies using it. Big companies and small companies alike. It's basically when they see something that fits the problem of, oh, we need a state machine for this, or oh, we need an actor model type solution for this, and we're working in a TypeScript project. They will do a Google search for, all right, which libraries use state machines and or the actor model, and they eventually run into XState, which we tirelessly maintain. So it's one of the most maintained state machine actor model libraries.
Yeah,
So
you posted on X, I think it was today or maybe yesterday, about how open source maintenance can be such a thankless job,
mhm.
for various reasons, and I feel that. Okay, so X state solves the problem of distributed state, and state that is maybe async and that can have race conditions and so on. It's interesting because listening to you speak about this, I sort of learn and realize that state management is such a ubiquitous problem. It's certainly more ubiquitous than I thought. And by ubiquitous, I just mean it's everywhere.
Mhm.
Because I think of companies like Neon, right, that do database migrations, among other things. And that is also just a state management problem because databases, if anything else, are just massive state stores. And when you have distributed replicated databases, then the state management of the database gets super hard, and then you have companies like Neon, etc., that help you do those migrations in a more seamless way. Whoa, my camera is having a seizure. But all that to say, awesome. Thank you for that. Okay, so you mentioned state sort of goes haywire in highly distributed and asynchronous environments. I'm curious then if how the interplay between XState for state management in these complex cases and things like CRDTs, so what is it? Conflict resistant data types, exactly, come into play.
Conflict free replicated data types, I believe.
Right. Because that's also sort of a primitive designed to solve distributed state problems. Is there some interplay there, or am I just sort of seeing dots that don't connect?
Sort of. And so by distributed, I just mean that there's many things happening in your app. So the basically XState is not like Kubernetes, where it's like you have you have a cluster of things just needing to work towards the same problem. It's and I guess distributed is the wrong word for this. It's more complex states. So basically, you have many things happening in your app. For example, our own editor at stately.ai/editor, there's so many things happening. You have to detect, is the user offline or not? Are they panning? Are they dragging? Are they editing a state? And then you have to batch those edits, etc. So there's just a lot of complexity in an application like that, and in just applications that you might use every day. We're using right now Google Docs, we're using Riverside, and those applications can get really complex. There's so many things a user could do. So XState really wrangles the problem of there's, many things a user could do. There's many events that could potentially happen. And those events can be from a user, or they could be some external events such as data coming in or some signal from something else just coming in. And you have to manage the state somehow so you don't end up in what's called an impossible state. And so an impossible state would be something like you have an error screen, but also it says that you successfully completed the operation. It's like, what? That should never happen. And so
Yeah.
XState is a way for organizing and managing that complexity so that it's simpler to reason about. Yeah, I
Okay.
lost the original question, but
No, that's
yeah.
perfect. Yeah, thanks. You've debunked a lot of potential misinterpretations around the use of the word distributed, so I appreciate that. Let's talk about state machines. You mentioned state. The real edge of XState is it does what it does. It organizes, as you put it, complex state using two things: state machines and the actor model. So I'd love to dive into both of those. Is it fair to say that XState basically represents a state machine as code, as JSON? And I want to, maybe before you answer that, talk about what a state machine is for listeners. And there's other episodes where we talk about state machines on the podcast that probably are out before this. But for those who haven't yet worked with state machines, I think it's an important thing to clarify, because it's not a machine in the way that you think of a machine. It's not a physical machine. It's not an industrial thing that gets input and does output, right? Like, we think of a machine as the camera I'm using or the microphone. Like, these are devices. A state machine is not a physical device, nor is it a human being that grinds really hard like Sean Wang or Swix. The dude's a machine, but it's a
He
big
is.
drawing. It's a big drawing, a
Mm-hmm.
diagram with states and transitions between the states. So it's like a bunch of circles with lines between them. It looks like a graph data structure. Just to clarify, and if I'm wrong, please correct me, but I think it's so important to capture that for those listening who maybe haven't yet been exposed to state machines, because you hear the word machine and you go, whoa.
Yeah.
Okay, the question there is XState, can we think of XState as expressing that type of drawing, but like as JSON, and then working with that drawing somehow programmatically?
Yeah, so one of XState's main purposes is to allow you to represent state machines and state charts, which the state charts are state machines. They take state machines to the next level. But I'm going to step back a little bit and sort of explain state machines for those who might not know in the simplest way. Tejas is right. Machines aren't physical devices, although it's funny and sort of ironic that state machines they were invented I think around the 1930s or just really early on, because they needed to be used in electronic devices. So like these physical devices that, they might have a board on it that, needs to control some electronic stuff. I don't do hardware, so I can't even BS terms with that. But the simplest way I could explain it, especially because it's 6:18 in the morning over here, I'll explain it in sort of an analogy. I was sleeping, and then my alarm woke off, said, "Hey, you have a podcast with Tejas." And so I transitioned to the awake state. And so I became I went from asleep to awake. Now, I can't be in both asleep and awake at the same time. Those are two completely different states. And also, there's many different ways that I could transition between the states. My alarm could go off. I could just naturally wake up, have to go to the bathroom, things like that. And then the other transition is possible too. I could go from awake to asleep. So if I put my head to bed, close my eyes, then I'm asleep. And so that asleep and awake, those are called finite states. And so if, like Tejas was mentioning, if you envision a diagram, those are like two different boxes. And then you have an arrow connecting those boxes saying, I will transition from the asleep to the awake state when this event happens. And that's pretty much it. Those are the fundamental concepts of a state machine. You have finite states, you have events, and then you have transitions, which, based on an event, transition you from one state to another. That's all it is. And so it's sort of easy to envision how essentially every single application you make is a state machine at some level or another.
Awesome. Thank you for that. So then does XState take this collection of finite states, events, and transitions and express them in code, and then give you APIs where you can just be like, go to the next state with a function call or similar.
Exactly. So the
Wow.
main way that XState works is that you define your state machines in sort of this JSON way. That was the API that was most visualizable. I know some people might be allergic to writing JSON, but that's the API we chose. And it's the one that like we're sort of like forward thinking. So we're like, okay, we want this to be compatible with other languages as well. So, JSON is just sort of this lingua franca for
Yeah.
logic. We don't want to use YAML, so we'll
Yeah.
just stick with JSON. But yeah, so you define your state machines in this JSON object, and then you put it in create machine, and then you have a state machine. And then you put that state machine in create actor, and now you have an actor, which is an instance of that state machine. So think of the state machine as DNA, and an actor is just someone who, like a live entity. It has that DNA, it knows how to behave based on that state machine. You could send it events, it has its own internal state. But yes, that's a long answer to your question that XState does basically make it easy for you to create state machines and to visualize them as well.
Oh, visualize them as well.
Yeah.
How?
Because
I mean, so do you then take this JSON and plug it into some type of visualization library and you get a graph? I knew about the create state machines and then interact with them part. I didn't. How do you visualize it by then uploading it to the Stately editor, or is there a way to do it like in code?
So we have this actually I'll sort of talk about the history. So we've had visualizers before where basically you're copying and pasting code. So you copy and paste the exact same JavaScript or TypeScript code that you wrote to a visualizer, and then the visualizer says, hey, this is XState, I can understand it, and I can visualize all of those boxes and arrows, those states and transitions that I was talking about. But now we have tools where it's called Stately Inspect, and this is also free and open source too, where basically you create an inspector, pass it into the actor you created, and there's a simple API for this, and then it will just pop up a new browser window and say, here's your state machine. We also have a VS Code extension that essentially does the same thing, but without you having to add any extra APIs. It's just a little text on top of your machine that says, hey, do you want to open this in the visualizer or the visual editor? And it will just pop it open right next to you. And so that's honestly the dream, where you could write code and then you have a visual representation of the code right next to you. So in short, yes, XState provides a way for you to visualize your application logic in visual state diagrams.
This is so cool. That I'm a little bit lost for words because I haven't ever used that, but it sounds like XState. So if somebody wanted to like show up, they maybe haven't heard of XState, they haven't heard of you, and they get inspired. They're like, whoa, I want to build a way to take a state machine diagram, and then turn it into JSON and give developers a programmatic way to interact with it and visualize it. It's only a matter of time then until they create XState, because that's what it does, right? So like this is almost, I'm thinking about like a challenge for listeners to learn XState and how it's built. Is they just like start by looking at a diagram, a state machine diagram, and then try and implement it as code. If they did that as a challenge, how close would they come to implementing? Would they just implement XState? Like a basic version of it?
I honestly probably, because there's two approaches, and I've looked at so many different state machine state libraries like that. There's the approach where you're basically imperatively building it up. You're like add state, add transition, etc. And that it's, I guess, easy for developers, especially if you're used to those Fluent builder-like interfaces, but it's very hard to visualize that. So if you give your listeners the constraints of this needs to be visualizable, you need to be able to copy paste this and visualize it somewhere, then they'd be like, okay, I need some sort of declarative structure, and ultimately you will end up building something like XState. And even if you don't know about XState, it's because the way we designed how you declaratively specify a machine is it's a mapping. You're mapping states, events, and transitions to other states. And so you would naturally think, okay, it's an object, like something on this here, on that here. It's like taking a switch case statement and sort of representing that in JSON. You're going to get very close to XState.
This is so cool. That's a challenge to anyone listening who wants to sort of understand this library and also, in so doing, level up their JavaScript and probably TypeScript game. Why don't you try implementing XState from scratch?
I encourage it.
Yeah, awesome. I say XState. I say TypeScript game specifically because I assume there's some really cool type inference type challenges there where you have state transitions or events with discrete names, and then across the state machine, you've got to have those names be type safe, right? Because it's better to work with transitions whose names you can predict as opposed to just a string type. Maybe we're getting too low in the details here, but I think that's a cool challenge for TypeScript. You mentioned state charts are distinct from state machines, and you said state charts take state machines to the next level. How?
Yeah, so first of all, state charts are state machines. They're just a different way of representing state machines. And this is going to sound weird coming from me, but state machines have some fundamental problems, like big problems. State machines, for example, like, you might say, okay, if you're modeling something where you're either asleep or awake, that's easy enough to do. However, if you're modeling more complex things, like, I don't know, I'm trying to think of an example, but I can't. However, there's times where you might add a state and then you're like, okay, we have another state, but you could transition to that state from any other state. So now you have to draw a bunch of arrows from one state to the other, or there's a set of states where, you could transition to that state. Basically, as the number of states and events grow, if just picture it as a diagram, the more boxes you add and the more events that are possible, the more arrows you have to add. And then all of a sudden, your state machines start to look like spaghetti. You've heard of spaghetti code.
Yeah.
This brings spaghetti to the visual level. Like, this is visually spaghetti. Like, you could think of the states as meatballs and the transitions as little, spaghetti noodles.
Yeah.
So state charts were actually invented in 1987 by a professor, Dr. David Harrell. And
wait a second. Sorry to interrupt you, but you said state charts 1987 and then state machine. So the original thing on which state charts are built was in the 30s. So there were like 50 years between state machines and state charts.
Yeah, around the 30s. Roughly. And that was Mealy and Moore, computer scientists, I believe. And then, in 1987, now you have state charts. And so states charts, they bring hierarchy to state machines. So you could actually have a state which has child states inside of it, and those child states can have child states. So you get this infinite amount of nesting, and you could transition from any part of, like, from a child to a parent, etc., or from child to child, from parents to child, etc. And you have a few other mechanisms too, like orthogonality or parallel states. So you could say, which sounds contradictory to what I said before, in which you could only be in one state at a time. But in reality, these are still finite states. And so what I mean by that is you could have something that represents a combination of states. For example, you are, or at least I am, awake and hungry. You might be, awake and not hungry, but it's like, aren't those two states? Like, how do I represent I'm awake, but I'm also hungry? So in reality, you're in that combination awake-hungry state. And so state charts just make that really easy to represent without you having to make a million states that, represent the combination of all of those states. And they have other mechanisms too, like the ability to say, hey, when you enter the states, then execute this action, which I think is really cool because now you bring effects into state management too, which historically hasn't really been done. Like, state management has just been, hey, when something happens, here's the next state. Or like, when you do this, then just update the states. It really doesn't care about effects. Even in something like Redux, it's like, yeah, we'll just shove that to middleware. The middleware can figure that out. But with something like state charts, it brings it into the actual application logic because it does consider it to still be part of that application logic. You have other mechanisms as well, such as history and things like that. But yeah, state charts are just real, like a really, really interesting way of representing state machines so that they scale.
And that's indeed, as we talked about, the original problems that XState solve are these highly complex problems. So it tracks that XState would model not just state machines, but state charts. Okay, you mentioned a number of things that I want to go deeper on. It's so interesting because I've never been exposed to this because I don't spend as much time in this world as you do. So I'm really thankful you're here. You mentioned orthogonality. That is the ability to be in two separate, distinct states at the same time.
Yes.
And you use the example of awake and hungry. I wonder how this plays with states that we may think are possible but aren't. For example, the state of, I'm thinking about lucid dreaming, right? So you're like sort of unconscious when you're asleep, but you're also conscious in your dream. Whoa! And so I guess that's where state charts really shine, is they maybe call into question the impossibility of states, and can they sort of highlight like poorly modeled state machine jobs? I'm curious if you could speak to that at all, or if I'm just sort of going off the rails here.
Yeah, no, I'll double click on. Oh, I'm sorry, I use the term double click, but I will dive deeper onto that, like just modeling smells in general. And this is
Yeah.
where something like state machines and state charts really help with, because if you have a problem in your application logic, TypeScript or whatever language you're using, it might say, yeah, it's fine. Like there's no red squigglies. Everything looks good. And in fact, you or your coworker is looking at the code, you might be like, yeah, I mean, it looks fine. It's syntactically correct. The white spacing is correct because people cared about that for some reason.
You're using tabs, not spaces.
Yeah, exactly. And then your users might not care either. They'd be like, yeah, the app works as expected, until they run into certain edge cases, or like they're like they click something and they're like, wait, an error occurred and there's no way for me to get out of this, or that was an unexpected state that I happened to be in. Now, rewind a bit and say that you went back in time and you used state machines and state charts instead, just a refactoring of your application logic to make use of these states and transitions. Now you have a visual representation of it, and you could visually see like, hey, we have a state here that's sort of orphaned. We forgot to add a line to it. Or it's like, hey, wait a minute, this state, it has lines to it, but it's an error state and there's no lines coming out of it. It's sort of like looking at a map or like a maze or something and being like, wait a minute, if we go here, there's no escape. There is no way out of here. There's no escape route. Or just like, hey, this room exists, which is entirely walls. Like there's no doors or windows or anything. And so that's something that humans can really easily see and be like, that doesn't look right. And so state machines really help with that, because it's like, like I said, it's those three fundamental concepts. You have states, events, and transitions. And so with all those Lego building blocks, you could see, that doesn't look right. This is something that we should refactor. And the other way around, like if you see like, hey, we need to add a new feature or something, it's like, okay, we add another state, another transition, and it sort of becomes clear how everything fits in. So that's why I really like the visual nature of state machines. It makes those problems really clear. It gives you a different lens to them.
Yeah, thank you for that. I wanted to ask you exactly about that. For context, we had, or will have, depending on when this is published, Artem Zakharchenko on the podcast. And Artem is sort of the leader of the testing movement, the automatic testing movement, in my opinion. Like he's partnered with Kent Dodds over at Epic Web, and he's like leading the charge on workshops about automated testing. And in our discussion, he mentioned how invaluable it is to start with tests always. And he didn't mention just starting with unit tests, but like maybe you build a prototype. So you're not religious about it. You build a rough prototype and then immediately you cover it with tests as soon as some behavior is working. So you maybe not start with tests, but you like testing comes very, very early, including like UI, like end to end. He's like, look, it's only expensive if you make it expensive. And anyway, that episode was very insightful to me because we talked about priorities. Okay. I'm hearing here that there's a huge amount of value in modeling your application's flow through time as a state chart or state machine. And, from there, your application just becomes more predictable for your developers and your users. And you make sure you're not ending up in some weird state where like, oh, we forgot to add a line here and now the user's lost. We're in a room with only walls and nothing else. So I hear the value. My question is, when should we add this value? And I'm asking you this as sort of the preeminent leader in the space, right? Like, do we, you can laugh at that, but it's true. I mean, do we start with the state chart before building a product and go like, okay, what are we doing here? Or do we build a prototype? Like at what stage in the software development lifecycle do state charts or state machines really add the most value? And I will preface this by saying, I once built an extremely complex piece of software. This was before the whole AI thing. This was in 2019, where it was automated vetting for code challenges submitted by job applicants. So we'd give them a code challenge with predefined rules. We didn't obviously share the rules, and they'd upload the code repo. And our system, the system that I designed, would unzip the file, read the thing, and make decisions based on the quality of the code. Of course, the final say was humans, but it helped humans a lot. And this thing, I realized how it was going to be so complex, and so I modeled it using a state machine first, and it was extremely insightful to me. Like I could literally see, oh, I haven't thought about that transition. I hadn't thought about that edge case. I hadn't, and so it made my software more robust to start with a state machine. Since then, I've not done that because I haven't considered the various products I've worked on to be like that complex that I would need a state machine. And so for me, it's like if I feel like it's going to get super complex, I would. But if it's just like a to-do list, I'm not going to do that. So I'm curious if, given all of that context, if you could speak to like when's the best time and for what use cases should we maybe start with state machines or not?
Yeah, so extremely good question. I would say that it's always a good time, and I know that that's sort of a wishy-washy answer, but it's really true. State machines, and at least this idea of software modeling, and especially visual software modeling, it's so useful at every stage of the software development lifecycle. So let's say that you are creating your app or your to-do app or something like that. Um, Even if it might seem simple, you still want to list out like, okay, what can people do in this to-do app? They could create a to-do, they could edit a to-do, they could remove a to-do, they can mark it as completed, etc. So all of those things I just listed are things that you would probably naturally think about where you're like, I want to build a to-do app. Here's all of the features, all of the use cases that I want from it. And just by listing it out, you're already doing software modeling at some extent. You're already modeling, here's how it's supposed to behave. Like you're an extremely experienced developer. I mean, even your live coding is like miles ahead of like what I've seen other developers do.
Thank you.
And basically, I don't think an experienced developer would just be like, oh, that's a problem, I'm just going to immediately start coding. No, it's like things are either going on in here, or you have a whiteboard, or you have something like that. So you are doing modeling at some extent, and state machines really help with that. Now, state machines are, formal structures, so it might seem like overkill to use a full state machine, but at least modeling things out where it's like, okay, if I'm building a shopping cart or like some sort of store or something, I could at least model some of the flows and be like, all right, well, the user could be taken here, 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 and here, and just draw a nice line with 5 or so states. And then you would, as you're starting to code, you could use that as a reference. So you don't need to use that in the actual code. You could just design it out and be like, okay, what I'm coding matches the idea or the model of the software that I've planned ahead of time. And also, like, let's say that you've decided not to, or you've already created a model, and you're really deep in the code. You've written thousands and thousands of lines, and you're like, okay, you were talking about testing, so it's like, well, now we need to test it either manually or writing end-to-end tests for it. Where do we even start? And so that's where things like state machines really help too, because instead of saying, the user logs in, they click this, and then they end up in this screen. And then you write another one, lather, rinse, repeat. It's like, wait a minute, just draw it out like a map where it's like the user, they could log in. That login could either succeed or it could fail. If it succeeds, the user could go here, here, or here. If it fails, they could click forgot password, or they could go back, they could try again. You're mapping all of that out. So now your tests become like, just draw a path from the start to every other state, and you could visually see, did we cover all of the use cases? Did we cover all of the paths? And so that's where state machines become really, really helpful there too. So really at all stages of the software development lifecycle, just modeling using state diagrams, it's extremely useful.
If there is though like an upfront time investment that what I'm hearing from you and your bias is that that time investment is worth it because it pays dividends over time. And this is also my experience with my big like AI software rating system. I just like, I'm wondering how to reconcile that with fast-paced VC startup, move fast, break things. Is it shipped yet? Where's the UI? Is it shipped yet? Where's it? And so if you tell someone like 2 weeks later, like, yeah, no, we're just like still modeling this thing as a state machine, and oh wait, so you haven't written any code? What? I was weaned in this culture. I don't know about you, but like for me, it's all about shipping. Like, why is my product not there yet? And if you tell someone, oh, I've just been drawing drawing a state chart, I don't know how long it is until you get laid off, unfortunately. So I don't know. Like, could you speak to that? Maybe we can talk about your company, Stately.ai, and how you built that. Did you do that when you were building Stately? Like, did you start with like, I'm going to model all of this first and then build my, I don't know, my editor? Or was it more like, I'm going to start building, then come to the state machine, then like a ping pong between the diagram and the application?
It was a mix of both, and I think that that's a really good example because Stately at Stately.ai, it's an example of something that's very, very complex. Like I would be hard pressed to find anyone who built something that's just like Stately.ai, which is basically a diagramming tool that outputs to code and also inputs from code. It's just super, super complex, at least on the coding side. And so as a startup, there were times where, first of all, XState, we have around 50 or so state machines just powering various parts of the application. But at the same time, we have a lot of legacy code where I decided to just do some cowboy programming. And I'm like, okay, I just need this to work. We're going to refactor this later. That later part has not come yet. So, there's stuff where it's like, and something that we've often said was like, I really wish this was a state machine. It's either something's a state machine or it's like, it should really, really be a state machine. But yeah, we definitely have a mix of both approaches. And especially in a startup world, something that we liked to do a lot as a team is even if we weren't going to use XState directly on something, we would at least pull up the Stately editor or even some other diagramming tool and model it out as a state machine. Because as far as the time investment for drawing boxes and arrows, you're looking at minutes. Like 5 minutes, like, hey, Tejas, can you draw me a quick flow of how you envision this feature to look like? It's going to take you like a few minutes on TL Draw or Excalidraw, whatever you're using. I really, really like TL Draw. But yeah, that's almost no investment. And that is a small investment that pays off really, really well. It's just coming up with a plan ahead of time. But doing something like learning the full power of state charts and all of its features and trying to adopt 100% of XState, of course, that's a huge investment. And it's not something that, unless you have a really, really good reason to do it, I would say, stick to the basics first. At least just use state machines in a modeling capacity, because that's going to be very, very little time investment. And it's going to really help a lot because that serves as documentation. When you need to add features, you could reference previous models that you've created and say like, okay, I know how this feature will fit into it. Or wait a minute, there's these things that we need to consider. So yeah.
Yeah, I think maybe, and I wonder if listeners can relate, but for me, I see forethought, and this is bad. This is me like confessing my own inadequacy here. I see forethought as like, this is going to slow me down. And I love that you directly debunk that by saying, look, it's just a 5-minute thing and just draw a diagram. It doesn't have to be a complex diagram. But my fear is, and I think this podcast is evidence of this fear. I'll tell you what I mean. I tend to have this tendency where I go down rabbit holes, David. I go down like long rabbit holes. And so for me, I'm scared of falling into the trap of, okay, I'll take 5 minutes to draw this diagram. But then I'm like, wait. What if, and I keep going. And then my 5 minutes turns into an hour. And I guess this is where my sort of apprehension comes from. However, in saying this, I realize it's actually good to go down that rabbit hole, because if you don't go down that rabbit hole at that stage, you're going to build some product that's going to have holes in it, literally, that you'll have to go down much, much later. So, yeah, so I'm just sort of preaching to myself here based on what the wisdom I got from you. And you know what? I think it's something that is definitely going to augment my software workflow. So thank you for that. Let's talk about transitions. You mentioned state machines have discrete finite states, and then there's transitions between them triggered by events. When I think of transitions, clear, right? Like it's the edges between the nodes. I also think of, my mind goes to Markov chains, because these pieces of these diagrams are basically, at least to me, state machines, because they represent a discrete amount of states, and and the probabilities of transition. That's basically a Markov chain. So you have like 4 different states, circle as you can think of them, and then there's lines between them. And above the line is like just a number, like the probability of this transition is this much, the probability of that transition is that much. And I'm no stranger to the idea that Markov chains are used in statistical analysis and predictions, and form the basis of like natural language processing, and over time are very closely connected to, if not directly influenced, the development of neural networks, deep learning, large language models, all the AI stuff today. So my question is there a path from state machines and their transitions to then predicting those transitions using something like Markov chains and ultimately putting the AI in Stately.ai? Or is that the connect? Or is, I guess another way of asking the question is, since you model everything ahead of time with state machines and transitions, and a state machine is a long-lived diagram that represents the logic flow or the flow of an application, is there value? Does XState help with predicting the next state as well? I guess you can. In theory, you can, as middle, and I'm thinking out loud here, but you could, every time you fire off an event, persist that event to some type of log, and then use all of that transition data to predict the next state. Okay, big question, but basically, what's the application of AI and XState, and why does Stately have Stately.ai?
Oh man, this has to be one of my favorite questions. First of all, stepping back to Markov chains, yes, you can represent Markov chains using finite state machines. Your intuition is absolutely correct. Like those boxes, or well, Markov chains are typically circles, so those like circles and arrows, like those are essentially, state machines. And like you said, you have you have Markov chains, and for those who don't know, Markov chains are just like predicting, or it's like a chain of, man, well, what's the best way to describe it? I would say like, all right, Tejas. So if I have a letter T, it's like, okay, what could the next letter be? It could be A, it could be E, I, O, like it could be a vowel, or I guess like consonant or something. So now let's say it's like E, right? So T, E, it's like, okay, is the next letter an X? Is it Texas? It's like, is the next letter a T or a P or whatever? It's like there's so many different possibilities, but then the third letter is J. And then all of a sudden, your Markov chain starts to narrow because there's only so many words that start with T, E, J. In fact, I can't think of anything else except Tejas, right? And so you could basically combine the entire dictionary into this one large Markov chain of like, all right, all of the words are represented in essentially this tree-like structure. So yeah, that's what a Markov chain is. And then you were talking about probabilistic Markov chains, where it's like when you go from E to J, the probability of that is much lower than something from E to X or E to some other common letter. You have a unique and a great name. So, yeah, and so bringing this back to finite state machines, this is actually like there's 2 angles to this. There's both the practical angle of like, how are state machines useful to me now, even if I don't care about the AI stuff? And then there's the future looking angle of how are state machines useful in the AI world, in the world of predictive analytics and things like that. And so the answer to both of those questions is that state machines provide this formal declarative structure for all of your application logic in a way that normal code does not. So you were talking about like we could encode things like states, transitions, and events. And so just like analytics tools like mixed panel segments, etc., they sort of capture everything. State machines can do that in exactly the same way, because the only way that something can happen is by an event. So an event causes a transition, and you could capture that. So imagine you have an append-only database where you just have a huge list of, here's all of the events that this state machine received. You could just replay those events, and because of what a state machine is, you will always, like, you are guaranteed to get to that same state if you just replay all of the events in exactly the same order. So now take that to the next level. You have this nice declarative representation of everything that could happen in your app, and add weights to it. So what are those weights? Those weights are what users are actually doing in the app. So let's say that I actually did this back when I was working at Microsoft in VS Live Share. We had the general flow modeled as a state machine, of course, by me. And so we could actually just take all of the events, and then I used D3 at the time, but I was able to create this visual diagram of it's sort of like a heat map, and we could see that like, hey, a lot of users who are trying to do this end up in some failure states. And so it was extremely clear. Like you could see this big, thick red line going from one state to another. And it's like, okay, let's dive into that. Let's investigate what's happening there. So now you have like these weighted transitions, so to speak, where you could visually see these transitions are being taken more often than these other transitions. And so, yes, you could feed that into AI and sort of essentially predicts user behavior. For example, if you modeled all the features in your application, you could actually see which features are clicking with people, like which ones people are using the most and which ones are not so much being used. And then you could see based on inputs such as like what kind of user is using the application, like what are they most likely to do next? Like given that they're in this state, when this event happens, what's going to happen next? And so you could extrapolate from that just user behavior. So I think there's a lot of really interesting applications. You could sort of tell that I've been thinking about this way too much, but yeah, it's exciting.
I don't think it's too much. I've been thinking about the same thing. And just to be clear, Markov. So I actually built. This is what I'm about to share is a great example of Markov chains, what they're useful for, and why when they fall apart. Because I built a Markov generator, which a Markov generator is just like is an application of the chain where a chain will help you predict the transition from state A to state B. And I loved your example of my name. Thank you for the compliment that it's unique. When I teach Markov chains, I typically use the weather as an example because the weather has, depending on how you interpret the weather, finite states. It's sunny today, it can be cloudy tomorrow, it can be snowy tomorrow, it can be rainy tomorrow. So we have 4 states, and you have a list of transitions. So from sunny to cloudy, from sunny to sunny, from sunny to snowy, etc. So you put these into a matrix, into a table where the rows are one state, the columns are another state, and it's just a mapping from this state to that state. And then you in the matrix you have the probabilities of transition from state A to state B, and that's your transition matrix. And if you then look at the most probable next step, or if you're in state A, the probability according to this transition matrix of transition to state B, that's the basis of a Markov chain. Anyway, so with that, I built a Markov generator, which is you just take the highest probability next thing based on the current thing. I built a generator of Kent C. Dodds's posts on X and Twitter, and I decided to build like, okay, if I could predict the next word from Kent based on the current word from Kent. So of course you give it a seed word like and you say, give me the next 10 words that come after this. This thing was kind of ridiculous and silly, and it was silly because of the Markov property, and that is you can only predict the next state based on the current state. So it's memoryless. It has no memory, right? And you were talking about assigning weights to transitions for UI. That is so cool because I think that's the key. Because you can, based on the weights, make decisions. And this is the basis of a neural network. It's like transitions with weights. That's all it is. And it becomes machine learning when you do backpropagation. So when you arrive at a target state and you go like, okay, what are all the transitions that led me here, and adjust for efficiency along the way. So I see a very clear line between XState, state machines, Markov chains, neural nets, deep learning, AI. Like that's very clear to me. And I'm really happy that you see that as well, and you're thinking about the same things. Does Stately, the visualizer, have affordances for this yet? Is that something y'all are working on? What does that look like in terms of like a productized version of this?
Yeah, so we are working on that. It's something that I thought about early on, and when looking for a domain name like Stately.com, of course, was taken. It's a fashion subscription brand. They keep emailing me saying like, "Hey, would you like a subscription?" But I have I have conference hoodies and T-shirts. That's my entire wardrobe. I don't really care. But no, we found Stately.ai, and I'm like, you know what? There's a lot of applications of state machines in AI, and even when you look at very basic AI, like let's say that you're playing Pac-Man, how do the ghosts operate? Like how do they know to chase you and to hunt you down and to eat you, or whatever they do to Pac-Man? I think Pac-Man eats ghosts, and ghosts just spook Pac-Man or whatever. But those are essentially powered by finite state machines, where it's like, depending on the state of the game and what's happening, the ghosts are going to behave a certain way, such as when Pac-Man eats one of those pills or whatever, it turns the ghost, or cherries, I think. It turns the ghosts into, well, it makes them transition to a fearful state where they run away. So state machines are actually the basis of very classical artificial intelligence in games. And then things evolved from state machines, such as behavior trees and, of course, state charts and things like that. But yeah, if you get further into it, yeah, state machine. Oh, sorry. Just getting into the original question. With Stately.ai, we've always thought about this, and it's always just been sort of a back in my, mind idea. And then once the whole AI craze slash bubble, like the LLM craze that we're in right now, came about, we're like, you know what, we could actually really use this to help people create and modify these state machines. So one of the features I use most on Stately.ai is you would enter a prompt or a set of user stories or a feature you would like to create, and it would actually create that starting state machine for you. And there's a lot of things that go into that, because obviously with LLMs, it's like you give it an input and you expect some sort of natural language text output. So it's like, how do you actually create something that's structured and, outputs an actual functioning state machine? And so we've managed to, use LLMs and, of course, XState itself to help do that. But thinking about what you were saying, yeah, I have so many future ideas on just how we could take this technology to the next level, how we could represent or derive state machines from large state spaces, such as all of the different ways a user can interact with an application, and how we could actually just take that, feed that into an agent, and have agents act like users, which really help, because it's like, imagine that you have an end-to-end test where it's like, make sure that the user can buy a product and that the user will actually want to buy a product. Like, how the heck do you test that? You can't really test like human psychology or human behavior like that. But now, let's say, like you said, let's say you have a huge Markov chain where you actually have a ton of user data on, like, here's how users actually behave. Put that into a state machine and say, like, is this transition more likely than the transition of them saying, you know what, I actually don't want to purchase this? And then now the connection between state machines and AI becomes really, really useful for things like predictive analytics and agents' behavior and things like that.
Yeah. Can we talk about that thing you built at Microsoft with the weighted transitions? Is that open source?
No, unfortunately, it's or actually it might be, and it might be gone by now. It was part of VS LiveShare, and given this was like over 5 years ago, things changed. So, but that was actually, it wasn't using XState. It was using that simple object mapping idea where it's like state, event, state, state, event, state. Like the exercise that your listeners will hopefully do in creating their own state machine. It was essentially that. And then we just fed that into D3, and then it just output a weighted graph.
But how did you calculate the weights? Were you on every event? Were you incrementing some type of counter and some type of state store, or?
Oh yeah. So basically we have transitions, and so a transition is state plus event. So like, given you're in the logged out state, you have a login event, so now you're in the logging in state. So that combination of log out state in login event, that's a transition. So we actually read, I think it was called Custo. We had analytics, so we were capturing all of those transitions, and then based on the count, so we just do a simple count, and so it's like, like, we could just map that to the weights on the graph.
Right. So these transitions happen super often, and so we probably normalize that to a percentage, and that's the percentage.
Exactly.
And it's probably a percent. Okay, cool. That makes sense. I think a killer feature for Stately would be back propagation and weight support. Because at that point, you're just creating like a neural net just in the product itself. And you could really demystify. I feel like, look, AI engineering is such a fascinating topic right now, because how do people define it? At this point in time, it's defined as just make a fetch request to some foundational model, or even a fine-tuned model. It doesn't, just make a request to like replicate and pull a response, and then use that response in your application. So it's the application of AI to solve problems. It's the application of AI in engineering, AI engineering. There you go. And that's cool. And it unlocks a lot of jobs and a lot of specialization, but I feel like it exacerbates the mystique around machine learning, especially in the front end space, right? Because you have people now like querying GPT-4, but feeling more imposter syndrome around conversations around like how is it trained and the ethics of it. Like all of this is just so lost on people, and I feel like Stately could play a role in like, no, this is how neural nets work, and we'll help you train your own basic rudimentary neural net, which is just weights plus back propagation. So I don't know, I don't want to tell you what features to add, but I think that's such a, like, I would be so enamored by such a feature because I haven't seen that anywhere on the web.
Yeah, no, I think that's really exciting. Yeah, so I guess there's the education angle of that, and there's also the basically just visualizing your app logic in terms of like this sort of rudimentary neural net. Like, yeah, just to summarize this topic, you were talking about Markov chains and them not having history, but then all of a sudden, if you add history, now you have RNNs or recurrence neural networks, and then now give those RNNs attention. I'm drastically simplifying this, but give those attention and say, hey, here's the specific history I care about, and now you have LLMs. Yeah. So it sort of all comes together.
Connected. I found something interesting that you said, because you're talking about state machines and that they were not necessarily invented, but first communicated in the 1930s. I didn't know that. That was surprising to me because Andrei Markov published his first paper on Markov chains in 1906. And so it almost is like Markov chains, which are really like close to finite state machines, were 30 years ahead of state machines. Absolutely wild. I wonder if we can talk a little bit about the actor model. Mm-hmm. This is the topic. This is something you're talking about at a number of conferences. Maybe we can just start by defining what that is. You sort of alluded to this earlier, where you create a machine with XState, and then you can create, I believe you said, create an actor from that machine. And you defined an actor as an instance of the machine. So you get a machine from create machine in XState, and then you get create actor, and you pass in the machine. What does that all mean? Like, what is an actor? Maybe fundamentally as a high level concept, and then in XState, what does it mean as an instance of a machine?
Yeah, so the actor model is another one of those really old computer science topics. It was invented in the, I think, around 1970s. There was Carl Hewitt, and then also Gul Aga, both professors or something. I don't know their exact professions, but yeah, point being is it's a really old topic. And you were talking about Markov chains. Like, state machines, I would argue, have been around since, this is going to sound crazy, but ancient times. Just going back in that, I know it sounds crazy, but they're technically called finite state automata. And if you think of an automaton, that's essentially what it is. So instead of a machine, it was called automaton. And that's a much more intimidating name than the machine. So I could imagine that's why they use the word machine instead. But in automaton, like, those toys where it's like you spin something and then like something pretends to like act or do something, like a figurine or something. It's like, oh wow, you're making something actually come to life just by spinning this thing. So you can imagine how that was created in ancient times, like with these cool mechanical properties. That's essentially a state machine or an automaton. So yeah, there you go.
So a crank and a lever is what it sounds like.
That. But like it could get really complex. Like they were basically child's toys where it's like you have two things like communicating with each other or pretending to eat food. Those kinds of toys.
I bet they used these to build the pyramids. I'm sure.
In some way.
Anyway,
but yeah, going to the actor model, another pretty old or relatively pretty old model of computing. I'm also going to explain this in simple terms, just like my sleep awake analogy. I am an actor. I am a paid actor. No, I'm just kidding. But like, if you consider me an actor and you an actor, so just think of actor in terms of entity, not someone who does something on TV or whatever, but just an entity. And as an actor, I can send you messages. So right now, that's what I'm doing. I'm talking to you. You cannot read my mind. I cannot read yours. So we all have our own internal state. And our internal state is what's going on inside here, our thoughts and everything like that. And the only way that you could really know some sort of representation of my internal state sorry, is if you ask me.
That's okay.
So you ask me, and I will respond with a message. So it's all about message passing. So we're actors passing messages to each other, and then depending on the messages we receive, we could change our internal state, and that's our behavior. So for example, hopefully not, but I might say something that triggers you, you might say something that triggers me, and then all of a sudden we're angry or something, or we might say something that makes each other really happy. So that changes our internal states, and that's our natural behavior. Our behavior dictates when the actor receives this message, this is how they're going to respond to it. And so that's essentially the actor model. They are these entities that have their own internal states, and they could receive messages, and they could also create other actors as well. So they could spawn actors, and then you have the fundamentals of distributed computing, because now you could envision these actors basically living either right next to the other actor or in some remote location, so some other server. It doesn't matter. It's location independent. And so, yeah, the actor model is just a way of modeling computation in terms of these actors that send messages to each other and have their own internal state. So just to bring it in a practical example, just like you could see state machines everywhere, you could see the actor model everywhere. A client is an actor. A server is an actor. How do clients and servers communicate? By using this protocol called HTTP. So same thing, message passing. They all have their own internal state.
Wow.
You can't read a database directly, believe it or not. You have to ask it. You have to make a GET request. Then the database will choose, do I actually want to send this person back some data? It's just message passing.
Wow. I can't unsee that. So the actor model has been around us this entire time.
Yeah.
And then with XState, I have a machine that models state transitions, and I pass it to create actor. And what do I get? Do I get something that can receive events and augment internal state? Is that the programming primitive I work with when I call create actor?
Essentially, yeah. So when you create a state machine, you're creating actor logic. So that's the behavior of how something works. To make another analogy, it's sort of like React. So when you create or when you define a component, like a button or a date picker or something like that, you're actually defining the logic for the component. You're saying this, like an instance of a component will have this internal state, so we'll have these use effects, hopefully not too many use effects, and it will render these things. But you're not actually defining an instance of a component. It's not like, oh, I want 5 date pickers, so you're going to copy and paste 5 different date picker functions. No, you're just defining the logic. And then in React, you're like, hey, I'm actually going to loop through this and create 5 different date pickers. Those are instances of that component. So you could think of the state machine as the component's definition, so the definition of the logic, and then an actor is an instance of that logic.
Right.
And it doesn't have to be a state machine. XState allows you to represent logic in things like reducers, promises, observables, etc. But it's all the same fundamental concept where you have an internal state, you receive an event, and you will transition to another state. And whether that transition is done by a state machine or a reducer function, that's totally up to you.
By a state machine or a reducer function, do you mean an actor or a reducer function?
No, so basically you do need that actor logic that says, if I'm in this state and I receive this event, then now I'm in this state. And that could be a simple function. And a state machine is just a more advanced way of representing that, or a more formalized way, rather. And a promise is sort of a simpler way, because it's like, I don't care what event you give me. I'm just waiting for an event that says, hey, you resolved or you rejected. That's the only events I care about. And then it will change its internal state to say, I have resolved or I've fulfilled, and here is my output.
Awesome.
Yeah.
Thank you for that. I want to talk about Stately in a more like narrative style. I also want to talk about your experience as a CEO. But I do have one final sort of question about XState, because I think it's just at the top of mind, and I find it super interesting. Can we like build in memory? And of course, there's a README. Of course, we'll include all of this in the show notes. But as a little exercise, a reasoning exercise, can we build a to-do app in memory using the actor model, just to understand. So this is my best guess, and you can maybe tell me where I'm wrong. I first model all my states and transitions as a JSON object, and I pass it to create machine. And this is my machine. I get const machine equals create machine, whatever. Then I get this machine and I pass it into create actor, and I get back an actor. Let's say it's identified by const actor. And it's a to-do list app. So I have states like done. Let's assume it's one to do, even for simplicity. I have a state like done, not yet done, invalid, maybe. What would that actor like? How, I don't know. This is where I'm lost. Is it actor dot act, and then I pass in the next state? This is where I'm, and of course there's a README and so on. But like for the people listening and who are now like entrenched in this discussion,
Yeah.
How would using an actor look like? What's its application?
Okay, so in actor, at least in XState, the actor interface is pretty simple. So you've already defined the logic. You're like, hey, here's a to-do app. You could add to-dos, delete to-dos, modify to-dos, which are all events. They're just events that you could send to the actor. And I just said the API. It's just actor.send. And so you would send create to do. You would send, so just like Redux or things like that, you would send update to do, you would send deletes to do. And then how do you get the states? Well, you could subscribe to the actor, because essentially an actor is a stream of different state changes. So you could do actor.subscribe, and then that states you could just observe every single state change. Or you could get the snapshot synchronously by calling actor.getSnapshot. And it's called snapshot in XState instead of states because state is meant to be internal. So a snapshot is a externally facing representation of that state, which might or might not be the actual internal state. So for example, if you're reading from a database, you're not getting the actual state of the database. You're giving whatever the database chooses to share with you based on, what you gave it. So you're getting a snapshot of the database. Yeah. So if you update that data, you're not really updating the database, hopefully.
Yeah.
So yeah.
Yeah. Oh, that's so cool. Okay, and now that you mention it like that, I see I see a whole multiverse of things open. For example, if I subscribe to an actor, and I get back a snapshot of the state every time something happens, including maybe an event, then I can propagate those transitions and or the state into some type of analytics database where then I can, calculate weights. I can do that. I can do this whole neural net piece we talked about by subscribing to an actor. I can also trigger new events, et cetera, et cetera. Okay, this is cool. Thank you for that. I fully understand now the application, because it also simplifies like application code. If you define a bunch of actors and export them, or even make them into NPM packages, because you can do that, right? Then you would, in an on-click handler for a button, just do like actor.send, and that's it. And then the logic follows. Okay, that's so cool. So it's a centralized way of also storing state transition and then dealing with that. That is so cool.
Thank you. That's essentially that's a very that's what XState is, really.
That's so cool. And you could also then create agents, right? Because you could subscribe to events in an environment, and have these agents that do tasks as well based on like what's happening in the environment. How far off am I from like something practical?
You're right on. In fact, I'm creating a package. I haven't really advertised it yet. It's called Stately Agent. So at Stately.ai/agent, we have some basic documentation. It basically makes it easy to work with LLMs, but essentially an agent in terms of AI. An agent is something that it sort of observes an environment, just like you described, and it takes action based on that, based on a goal. So an agent might have the goal of win this chess game, and so based on the environment, which is the chessboard and the move that the player just made, it's going to decide, okay, I'm going to move this piece here because I think that there is a path to reaching that eventual goal. And so it might have this internal state machine of like, here's how the game operates. And it could use that state machine to evaluate, here's all of the different possible, possible plays that I could make. And here's the one that's probably going to get me closest to winning. So yeah, you're absolutely right. An actor is just something that has internal state, receives events, and it determines what to do based on the events it received. And so that's what an agent does too. So honestly, they're exactly the same.
This is cool. I could then build using XState. Man, you've unlocked so many ideas based on this discussion. I could build a state machine that is modeled after some type of conference. Let's say, I don't know, JSConf Budapest. You're going to be there. I can build a state machine that models a bunch of states such that conference happening, conference scheduled, CFP announced, conference happened, something like that, and transitions between them. And I could, like, going from there, from the basis of that state machine, build an agent that when the transition happens to CFP announced, then go submit a CFP. And if this agent package, stately agents, integrates with LLMs, I could have it even generate a title and abstract for me. That is completely novel based on things I've just been talking about on social media. Whoa, that's wild. I need to play with this package, even if there's rudimentary documentation. That is so cool. You could literally build yourself a Jarvis. And it's pro. So I've been thinking about this, and this is a tangent I don't know if we should go down. I'm happy to, but like,
I love it.
I've been thinking about this, about AI and LLMs. An inherent limitation today is that a lot of it is reactive instead of proactive. Like, you have to give it a prompt and then it helps you. But I know some folks in the space that are working towards AGI through proactive AI. But AGI, by the way, just artificial general intelligence. And one limitation is AI is reactive, not proactive. But there's folks over at Vela. This is Kyle Simpson, the author of You Don't Know JavaScript Yet. He's now co-founded a company called Vela, VELLA.ai. And their whole business is, we're going to make AI proactive. I can hear you typing and looking up.
Yeah.
But so what they do is, it's local first, so your data is protected, and you log in with various providers, and in a secure way, they sort of read your notifications and proactively, like, prompt you, like, just so you know, you're having dinner in 2 weeks and you haven't had Mexican in a while, so maybe make a reservation at that place. In fact, I make it for you. Wild, right? So I see stately agents as solving this case, and that's a future I'm super excited about.
Yeah, and to bring it full circle, I think that state machines are extremely useful in AI programming. So not just the original example I talked about where they're using game programming, but actually for agent behavior, because you do want something that AI is sorely missing today, and some of the disadvantages of using AI are it's not deterministic, which means given an input, you might get different outputs. It's not predictable. You have no idea what the AI is doing. So, and it's not explainable. You have no idea why an AI, like an LLM or something, reaches a certain conclusion or decides to do something. So state machines are like the polar opposite, but they could be used with AI because they provide constraints. They provide guardrails for it. One of the best examples I've seen was, I think someone posted this on X or Twitter or something, where they were basically just, there was a car chatbot or something, or I'm not sure if it was a car, just some other website. They had a chatbot, of course, like websites love to do. They're like, hey, now we could replace our humans with this AI LLM powered chatbot, and its main purpose is to help you out. However, this person was doing homework, and it's like, hey, I don't really care about that, but please solve this math problem for me. And it's like free chat GPT. And because the agent was like, oh yeah, sure, I could help you with that. And, there were no constraints. It's just like, hey, give me an input, I'll give you an output. However, with things like what you were talking about, filling out a CFP, etc., it's like, there are times where you do want even these free LLM agents to actually follow a specified path and follow a certain series of steps to reach a goal, which is, fill out a CFP for me or do these things in this specific order. And so that's where state machines can really, really help out there.
Yeah, and they can also probably play a role in making sure the machines don't kill us all and take over the world. As you talked about guardrails.
Yes.
Not that I'm a doomer, but if you ever meet a doomer, you can just be like, no, state machines, it's okay, it's going to be solved. Yeah. Cool. Let's talk about Stately. You built this library, extremely popular. I'm assuming you built it when you were working at Microsoft. I don't know if you built it on the job at Microsoft and then open sourced it. Whatever.
It was before Microsoft. Okay. Yeah.
Oh, is that why Microsoft hired you?
No. They actually hired me because I built a form library in Redux, and then I gave up on that form library. So, yeah.
Gosh. Wow, I didn't know that. Okay, so you built XState. It has proven value time and time again. And you joined Microsoft, and after a while, you decided, I'm going to leave Microsoft and productize XState, by adding this layer of a visualizer. And so, can you, in as many words as you like, talk about introduce Stately, maybe the journey there, the product offering, and where it's going tomorrow?
Sure. So in short, I just wanted to work on XState full time. It was the middle of the pandemic, and I was really just dying to do it. There were more and more companies depending on XState, and I just realized that I needed a lot more resources then. Basically, it was just me and Matoush on the project working on it, nights and weekends. I even had to wake up early, and just basically like we talked about briefly before, open source is sort of almost a thankless job. You're doing a lot of things for free, and it's not really sustainable unless you have some corporate backing or a huge amount of just contributions and support from other people. So yeah, this was my opportunity to sort of just go the VC funded route and actually turn this into a product. And so the main idea of it was we were basically going to take the idea of XState, which is this visual modeling of application logic, and make it accessible to a lot more people. And we did this by the use of visual diagramming tools such as we had Stately Viz, and then that turned into the Stately editor, and a way for teams and individual developers to create, modify, version, and share their machines, but also just have an easy way to basically use that as living documentation that transforms directly into code, or the other way around if you wanted to. So we want to bring basically diagramming and documentation to the next level, and so that's what we did, and we're still working on at Stately.ai.
Fantastic. I'm curious if there was ever I see a big trend, by the way, of companies starting because open source is not sustainable. Companies like Cal.com, companies like Crab Nebula, which is like Tauri, which is an open source project, and they this doesn't pay the bills, and you start a company,
right?
And of course build a product. I have Chad from Sentry on the podcast. He's the head of open source, and they're doing some fun stuff around making open source sustainable. But I'm curious if y'all considered for a moment the consulting route as well, like have a product, but also because I see this trend a lot. I think of Crab Nebula, great example. They have like Crab Nebula Cloud, which is like distributed application distribution globally, because a lot of folks are just distributing binaries with GitHub releases, which isn't really Edge CDN powered, and so they're just adding a CDN to that, among other powerful features as a product. But on the way to shipping the product was like, we're just going to do consulting contracts because we built this open source thing and it's in use at enterprises, so it made sense. Is that something y'all pursued in the early days?
In the early days, yes, for sure. But you will typically hear common advice that consulting, it's sort of, obviously people make livings off of consulting and being consultants, but in terms of a startup, it doesn't scale. So it's something that you should actually tend to avoid, because it's like you're spending an hour of your time to help, or a couple hours to help one person, one company, when instead you could spend that 1 hour doing things that scale out and help multiple companies or like marketing efforts and things like that. So we started down that route, and I don't have too much time to do it. But with that said, we do have, we do consulting at Stately.ai.
Awesome. So it's this product and consulting, and the product is a visual complement to XState, where you can really intensively model state charts, not state machines. So as I understand, you have child states, you have all these other powerful primitives, and then you export to JSON that you can then pick up in your application and just fill in like application logic. The state machine's built for you. And I appreciate that you also said about Stately.ai, the product, that it can take code as input as well to a diagram. So it's a really cool product. I've used it myself. I'm a huge fan. You founded this. It's your first time founding a company, as far as I know. It's also your first time being the CEO. I posted something controversial on LinkedIn where I said, you know what, maybe we should just call first-time CEOs junior CEOs. And I didn't say that disparagingly. I just said it would set the expectation that this is their first time doing it and they need support from the team, as opposed to what I've seen is with the first-time CEOs, team members show up with like unrealistic expectations. Like, what do you mean you don't have all the answers? You're the CEO, and you're like,
Mhm.
no, but I did. This is my first time. So my thesis was, if you add junior to the title, it'll help people be a bit more compassionate and understanding. Regardless of that post, I'm curious if you could speak a bit to your experience as a first-time CEO. Maybe the challenges, but I'm more interested in like the salient important features. Like, what is really important for a first time CEO to know and care about, and maybe what is really most important in a recurring salient way for even experienced, excuse me, because you've mentioned 3 years, experienced CEOs to care about and have sort of at the forefront of their
I
mind.
mean, I'm still learning, and I really like your framing of the junior CEO, because I definitely do consider like I'm a first time founder. Like, I'm not going to pretend to be something I'm
Yeah.
not. I'm still learning along the way, and that's why I'm also going to say sort of a, I don't know if it's controversial or not, but a like an important thing for founders and first time CEOs to do is to make mistakes. I've made plenty, and
Yeah.
the trick though is to realize the mistakes you're making, because I think that when
Mm.
you become second time, third time founder, or you become a CEO at another company, it's not like you read up all these books or you went to school for this and you're like, hey, I know how to be a CEO now. Your knowledge is the collection of all the mistakes that you've made. And so like, hey, we're going
Beautiful.
to do this because when I did it the other way, that failed horribly. So we're not going to do it that way. So I think it's important to just realize the mistakes you're making and sort of learn from them. And I mean, I've definitely made plenty. Like, there's been times where we've been stuck in this whole like, hey, I think these features will be really cool. People are asking for this, and that. So we're going to build all of these. And also, people are like, oh, this would be really great if it were free. So it's like, yeah, sure, let's make a bunch of things free. And then you realize that your free users are not really they're never going to, or almost never going to pay. Like, that's not your target audience. So you want to build free features if you want to, just to get people in the door. And then you really want to focus on the people who say, I have a real use case and we want to pay you money. Those are the people you should be focusing
Mhm.
on.
That's so interesting. Yeah, I've seen this trap that a lot of founders fall into. I feel like this is especially hard for you as an open source author and maintainer, because all you're used to is free people,
Mm-hmm.
free users going like, I want more of this and more of that, right? And so it's a different beast when you're running a business. But then, how do you find those people? The people who say, "Hey, I want this and I want to pay money for it."
Well, I mean, you start charging. You put things behind paywalls, and I don't want to be that person who says, hey, that thing that used to be free, well, we're making it paid. I really do firmly believe that if you offer something for free, just keep it for free. But any new things or things that will actually have value to people who might want to pay, definitely put it behind the paywall, because your time is valuable, the development effort, there's a huge cost to that. And so you do want to, just have people pay for it. Like, your product is worth something. So,
Yeah.
yeah, and so that's what we do. We have things where it's like, hey, if you want to use this advanced feature, something pops up, it talks about the advantages, and it talks about going pro, like we call it, Stately Pro. And so it encourages people to say, hey, there is the option to pay if you want to support and you want to use these more advanced features.
I heard I had a discussion on this podcast with another founder, and I'm totally blanking here, which is really bad of me, because I should ideally remember every conversation I have. But like, there was this one founder who mentioned, oh yes, it wasn't even a founder; it was Jeff Escalante,
Yeah.
director of engineering at Clerk,
Mm-hmm.
absolute genius in terms of engineering leadership, and he said this really powerful thing. And I brought up Stately also, by the way, because we were talking about road mapping,
Yeah.
engineering road mapping, and y'all use Canny. That came to mind in my discussion with Jeff. By the way, that episode's probably out, go have a look. I'm not telling you, I'm telling the listeners, just to be clear. But Jeff he found this product called Product Lane, and it's basically Canny but deeply integrated with linear. So you don't have to do anything. Like, your linear issues that you want exposed are exposed. People can upvote them, comment on them, etc. And it's this beautiful two-way data binding with. It's like a public interface to linear. Really cool. And then the priority is determined by your community or your customer base. And so Jeff saw this product, and he was like, "Yo, I love this product." And what he did was he reached out to them and said, "Listen, I this is valuable for us. We are tempted to use your free tier. We realize you don't have pricing figured out because it's too early, but we want to pay you. So give us a price. In fact, put us. You don't have an enterprise tier, but like invent one because we want to be on it, and we'll walk you through the process of inventing one because he's done this at Vercel, as far as I know. And he talked about the value of really, as a company, doing that to other companies, because then you invest in like the long-term relationship, as opposed to I'm just going to mooch off of this free tier. So I love what you said. I love that you said, put a paywall behind it and the right users will come. I think there's maybe a mandate here for companies in a position to be paying customers to do so. I've only unfortunately been a part of startups that went like, is there a free tier? No, we're not using it. But I think there's something inspiring there. Cool. David, I want to wrap up with, I want to talk to you about what's next for Stately. You mentioned stately.ai/agent or agents.
Agents,
correct
yes.
me. Agents. Okay, is that what's next? What else is coming?
Yeah, so of course we have the AI stuff with Stately.ai. That's something I'm extremely excited about because, like we talked about for half the podcast, it opens up a whole new world on thinking about the future of AI applications. The next big thing that we're planning on releasing is we are updating the VS Code extension, which has been used heavily by, of course, XState v4 users, but it does need to be brought up to date. And honestly, this is like the core of our product, which is the magic of your coding and you see the diagram updated in real time. It's like live living documentation, but you could also, it's sort of like a magic trick. You go the other way around. You could edit the diagram and the code updates. So, we're just sort of working on that magic between those two. It's an extremely difficult problem to solve, and we've been working for years on it, but hopefully we could have something out eventually for that. But other than that, we're just going to keep improving the tooling, and we're also hoping to make Stately basically the way that anyone, no matter which libraries, frameworks, or even programming languages you're using, you can make use of these tools either at a simple level of diagramming state machines for your application or just visualizing the logic. Regardless of if you're using XState or not, we want to provide tools for more and more companies to to visually model their software or their application logic. So we're just going to keep working on that.
That's so cool. I can't wait to play with all of it. Listen, David, it's been, as always, an absolute pleasure to talk to you. Whether it's over coffee at 6 a.m. in some city that I can't remember, or on the podcast. When you ship that two-way data binding and magic, I think we should maybe do this again. I would love to talk about the internal details of how that works.
Ooh,
because
that'd be fun.
I imagine there's walking the syntax tree and making connections between object literals and SVG elements or something like that. I don't know, but this sounds really interesting. Regardless, thank you for getting up at 6 o'clock in the morning and despite your hunger and thirst for coming on the podcast and sharing all of these insights, all the way from why XState exists to its application in neural nets and Markov chains, through to Stately and today and what's next. On behalf of me and all the listeners, it's an absolute blessing. Thank you.
Thank you so much for having me on. It's always great to talk to you.
Thank you for joining my discussion with David Khourshid. I hope you learned a lot about state machines, state management, when to manage state, XState, Stately Agent, and more. I certainly learned a number of things. For example, the distinction between state charts and state machines. I genuinely didn't know that because I didn't have much overlap in my day job. And that's kind of the point of this podcast. You get exposed to things you maybe don't get exposed to at work, here on the podcast, and that deepens your understanding and removes your imposter syndrome, all while celebrating the beauty of engineering. If you're learning from and or enjoying this content on YouTube, then if you subscribe to the channel and maybe like it, that'd be super helpful. If you're listening on Apple or Spotify, if you could leave up to a 5-star review, that would be helpful. It's just, all of this doesn't cost you much, and it does benefit the channel more than you know. So any of that would be appreciated. If you learned something, if you want to share a clip or so on social media, I will not stop you. Thank you for being a part of this podcast. Thank you for being a part of the discussion. And most importantly, thank you for your interest in engineering.